Hello everyone, and today we are going to be doing exponent properties for your algebra class. Now, there are 8 exponent laws that you should know. Okay, there's 8 of them. Okay, you can write these down in your notes if you want. There's a multiplication rule, where if you have x times x, that will equal x to the power of 1 plus 1, which equals x squared. Now, with this property, you will add the exponents. When we have like bases with x's as our base, we can add the exponents to the top like this. So we add these, 1 plus 1, that equals 2, okay? And then the next property is the division property. So if I have x cubed, or to the third power, times divided by x, let's say squared, x squared, that equals x to the 3 minus 2 power, which equals x to the first, that's x. Okay, so there's a division property. And then there is the power property. You take x, let's say x cubed, and then we raise that to the third power. That equals x to the 3 times 3 power, which equals x to the 9th. So when we have an exponent raised to an exponent in parentheses, we're going to multiply it, okay? Now we're going to be doing 2 products raised to a power. So we're going to let's do xy raised to the third power. That's going to equal x cubed, y cubed. Because you can just drag that exponent right into the products right there. Now we have the fraction rule. We're going to do x over y, all raised to the third power. That's going to equal x cubed over y cubed, because you can just drag that exponent in there. Okay. Now we have the 0 rule. It states that anything to the 0 power will equal 1. Now, some people say that 0 to the 0 is not 1. Some people say that's undefined. That's a heavily debated thing in math. But the consensus is that it doesn't equal 1. But make of that what you will. Now, a negative exponent, it says that x to the negative 1 equals 1 over x to the 1, which equals 1 over x. Okay. So when we have a negative exponent, we take the reciprocal, we flip it. Since there's an imaginary 1 here, we can flip it, okay? Now we go to our 8th property, which is with square roots. So it says that x to the, let's say, 5 over 2 equals x to the 5th, or the square root of x to the 5th. Okay? So with here, it's always power over root. Okay, so the root, the square root, and the 5 is the power. It can also be rewritten as this. So the square root of x raised to the 5th, like that. Okay? Let's try some examples. Okay. Let's do the multiplication rule. So if I have 5 to the second power times 5 to the second power, what is that equal to? Okay, what is that equal to? Well, given our multiplication property, we can add the exponents, okay? So this is going to be equal to 5 to the 2 plus 2 power, which equals 5 to the 4th. Okay? And if you want to simplify that further, that'll equal 625. Sometimes if the exponents are too big, you cannot simplify it further. But in this case, you probably could. Let's try another one. 6 to the second power times 6 to the third power is equal to 6 to the 3 plus 2 power, which equals 6 to the 5th. Okay? Now, if I had a problem like 4 to the second times 3 to the second, that equals, well, we can't add the exponents because they don't have the same base. So if you're wondering what that would be equal to, that would be equal to 16, which is 4 squared, times 9, 3 squared, that equals 144. Okay, but we can't multiply that, or we can't add that, because they don't have the same base, these exponents. Now let's move on to our division property. We have, let's do 8 to the 4th power over 8 to the 1st power, or just 8. If we don't write an exponent there, it's always 8 to the 1st power. So that equals 8 to the 4 minus 1, which equals 8 to the 3rd. You could probably multiply that out, which is 512. Okay. Now let's try another one. Let's do 7 to the 7th over 7 to the 4th. What does that equal to? I want you to try that on your own. Well, this equals 7 to the 7 minus 4 power, which equals 7 to the 3rd power. And that equals 343. Okay? So I think we all have the division property and the multiplication property pretty solid. Let's go to some harder ones. So if I have 5 to the 2nd power raised to the 6th power, that equals 5, and I want you to try that on your own. 5 to the what power? It's equal to 5 to the 2 times 6 power, which equals 5 to the 12th. Okay? Now this works because we write this out 6 times. That's what exponents are. We just rewrite everything. Okay? We rewrite it to where we don't have to multiply all of them out constantly. Okay? So you should have gotten 5 to the 12th. Okay? Let's do another one where you might get confused on. Let's do 5. Well, what if we did 5 raised to the 2nd raised to the 6th without parentheses? What does that equal to? Now, we can't simply multiply these because there's no parentheses. We're not raising anything specific to a power. So what we do is we need to do this highest exponent first, which is 6, and the base is 2. So we're going to do 5 to the 2 times 2 times 2 times 2 times 2 times 2 power. And that's equal to 5 to the 64th, which is way different from 5 to the 12th. So I recommend, you probably won't see a problem like that on the test, but that's just for future reference. We don't want to get confused on that, okay? Again, not a bad property. Not too bad. Let's do this one. What if we have, let's do 10 times 8 all raised to the second power. What is that? Well, we said before that when products are being when the two numbers are being multiplied like this, for example, x, y, and that's raised to the a power, that'll equal x to the a, y to the a. They're just being multiplied, right? And that's the same case for here. So this will equal 10 squared times 8 squared. And if you can simplify the exponents and multiply it out, that helps. Which is, then this is equal to 100 times 64. Pull over the zeros here. Is equal to 6,400. Okay. How about you try one on your own? The product law. Trying to clear this up here. Let's do 4 times 16 raised to the 5th power. And that's equal to, what is that equal to? I want you to try that on your own. Okay. Well, this is equal to 4 to the 5th times 16 to the 5th. And I'm glad I chose a problem like this because you can simplify this further, believe it or not. A big thing, this should probably be included as well. A big thing about numbers is that you can rewrite them all the time, right? What is 16 equal to? It's equal to 4 squared, right? 4 to the 2nd power. So I can rewrite this as 4 to the 5th times 4 squared to the 5th, okay? When we rewrite a number, it always has to be in parentheses like that, okay? Now, given our other property of raising exponents to exponents, we can just drag that in. So that's 4 to the 2 times 5 power. So this equals 4 to the 5th times 4 to the 2 times 5, which is 10, okay? This equals 4 to the 5 plus 10, which equals 4 to the 15th. Okay? You can... Now, we could have rewrote these with a base of 2, but we did it with a base of 4. So if you can rewrite the exponents and simplify it further, please do so. So we had a 4 there. So I rewrote it to simplify it more, okay? So you want to make sure you know your squares and cubes well to make sure you can rewrite those. This is a big thing when you're solving. We'll touch up on this more when we solve like exponential equations or other equations that we need to rewrite things for, okay? So you want to make sure you have a good grasp of that. And we'll touch up more on this later. Now, our next law is the fraction law, okay? So it states that 5 over 4 raised to the 2nd power. What is that? Okay, what is that? That means that we can just drag the exponent into the fraction, okay? So this equals 5 squared over 4 squared, okay? Now, by now we should know what 5 squared is. That's 25. It's 5 times 5. And that's over 4 squared, which is 16. So that's our answer. Okay. I'm going to try to touch up on the harder properties and not the easier ones just to make things go quicker, okay? Now we have the 0 exponent, okay? Anything to the 0 power, except for maybe 0, is equal to 1. So if I have 5 to the 0, that equals 1. If I have 6 to the 0, that equals 1. 1 to the 0, that equals 1. 1 over 10 to the 0, that equals 1. If I have a million equal to the 0, or a million raised to the 0, that equals 1. Okay, anything to the 0 except for maybe 0 equals 1. Okay. Now let's do the negative exponent. This will be a very crucial part to understanding exponent properties, okay? So let's try this one. Let's do 5 to the 3rd power over 5 to the negative 4th power, okay? Whenever we have a negative exponent, it will always be flipped to the other side of the fraction. So this is the numerator, and this is the denominator. Okay? Since this 5 to the 4th is on the denominator, we're going to flip it to the numerator. And when we flip it, it's going to be multiplied. Okay? Since this is division, we just flipped it to multiplication up here, okay? Now, our adding or multiplication property, we just do 5 to the 3 plus 4, which equals 5 to the 7th. Okay? If you're struggling to remember these properties, you can write them down if you want, because this can be a lot to memorize. So, yeah. Now, let's do another one. Let's do something like, let's do 3 to the 5 over 2 power. And that equals, what does that equal? I want you to figure that out yourself. Okay. That's equal to the square root of 3 raised to the 5th power. It can also be rewritten as just the square root of 3 all raised to the 5th power. You can it doesn't have to be like within the square, the exponent doesn't have to be within the square root. It can be outside of it, doesn't really matter. Okay. Just gonna erase this here. Or I guess. Now, 3 to the 5th power, you can plug that in your calculator. That's just 243. And the square root of that, okay? Now, we don't have to include the 2 right there. If we include a root without a number, it's just square root, okay? Now, let's apply all these rules. Sorry about that. Let's apply all these rules with some more practice problems. These were very basic problems. So let's do something like 4 x to the 5th, y to the 10th, over 12. Let's do x to the 7th. And then y. Okay, how do we simplify this? Well, when we have normal numbers like this, what we can do is we can just divide the equation or divide the fraction by 4. Okay. Divide it by a common factor. Okay. This equals 1 x to the 5th, y to the 10th, over 3 x to the 7th, y. Now, you don't have to include the 1. In fact, you probably shouldn't, because it just You don't want it there. So that's x to the 5th, y to the 10th. Okay? Now, how do we simplify this further? Well, with our subtraction or division law, we can subtract these, okay? So we're going to do x, we're going to take out a 5 from here, and we're going to take out a 5 from there, leaving us with a 2 at the bottom. Now, when we subtract, we need to take out the largest from the top, okay? So this goes away because x to the 0 is 1. So we have y to the 10th over 3x squared y. Okay? We can simplify this further, though. Y to the y is equal to y to the 1. So what we can do is we can subtract these, reduce these, 0, reduce that, 9. So we have y to the 9 over 3x squared. That's the answer for that one. Okay? Now let's erase all this. Let's do another one. Let's do something like 5x to the 29th y cubed over, let's do 15x to the 29th y squared, which is all raised to the 3rd power. Okay. Now we have two options here. We can either cube all of this, can raise it to the 3rd power first by dragging in the exponent, or we can use order of operations and just simplify what's in the parentheses. Okay? I want to simplify it in the parentheses first just because it'll look cleaner and there's not much more and we don't have to simplify as much. So let's do this. What is x to the 29th over x to the 29th? These cancel completely, okay? Because 29 minus 29 is 0 and x to the 0 is 1. So those cancel completely, okay? So we have 5y cubed over 15y squared. Now 15 equals 5 times 3, so a 5 for a 5. So we replace by a 3. So that's y cubed, or I should be raising this to the 3rd power. It's y cubed over 3y squared. And this equals, what does that equal? Well, y cubed divided by y squared is just y, right? Because we're subtracting the exponents. Y to the 1st, which is also y. So that's y over 3. This gets reduced to a 0, reduced to a 1. And that's raised to the 3rd power. And then with our laws of exponents, that fraction rule, we can just drag that power in there, okay? So this equals y cubed over 3 to the 3rd, which equals y cubed over 27. I'll rewrite that better. So that's y cubed over 27. That's our final answer. So we can't simplify it more. Okay. Let's do a couple more. And I want to make sure we touch up on this too. The square root of x equals x raised to the 1/2 power. That is something you'll want to know as well. Okay? Same with the cubed root of x. That equals x to the 1/3 power. It's power over root, okay? So 1 is the power, 3 is the root. Right there. Okay? Let's do another one. Let's do something like, let's do y to the 3 over 2 over, let's do y to the 3 over 4. Okay? When we simplify exponents, we don't want to have any negative or fractional exponents. Okay? Or sorry, we don't want any negative, we don't want any negative exponents, okay? And we can rewrite them as just cubed roots or square, just write them in the root, honestly. So these don't have the same, so this is equal to 3 over 2 minus 3 over 4. These don't have the same denominator, so we can't subtract them. So 3 over 2 is equal to, I'm going to multiply top and bottom by 2, which equals to 2 times 3 is 6, 2 times 2 is 4. So this is equal to y to the 6 over 4 minus 3 over 4. 6 minus 3 is 3. Denominators stay the same. So that's y to the 3 over 4. Okay, and we don't really like to leave it as a fraction, so we're going to do power over root. So it's the 4th root of y raised to the 3rd power. Okay, that's what that equals. Okay. Let's try one more problem, okay? Then we can be done for the day. Let's do y to the 3rd power raised to the 2nd power. And then let's add a z right here. Let's do a z. Let's do let's do a z over 5 5z cubed. Yeah, let's do that. Okay. And then let's raise this to the 2nd power. Or let's raise it to the 3rd power. So what is y cubed raised to the 2nd power? How do we do that? Well, that's equal to y to the 3 times 2 power, which will be y to the 6. Okay. Now, let's do the bottom now. Or that should be to the 3rd power. How do we simplify that? Well, we can just drag the exponent and when we multiply numbers, okay? With our product property. So that's that's y to the 6z over 5 to the 3rd z to the, now we have z cubed raised to the 3rd power. So that's 3 times 3, which is 9. Okay. Now, 5 to the 3rd power, what is that? Let's use your calculator. That's 5 times 5 times 5, which is 125. Now, there's an imaginary 1 above this z, because we should know that x equals x to the 1. So when you have a number and there's no exponent, the exponent there is just a 1, okay? So we have y to the 6 z over 125 z to the 9th. 1 minus, so let's get rid of the z. So we got rid of 1 z on the top and bottom. And this equals y to the 6 over 125 z to the 8th. Okay? So that would be the answer for that one. So just remember your laws of exponents. There's a lot to write down, but they really aren't too bad. You could get the hang of them pretty quickly. Yeah. I hope you found this video helpful, and if you did, please leave a like, and if you have any questions, please leave them in the comments. Thank you.